In this exercise, we are going to evaluate formulas. For this, we need an interpretation. Basically, the most part of that you can see on the screen is the description of the interpretation we have to work with. First of all, the domain is given. It contains 4 numbers, 1, 2, 3, and 4. Then we have a constant c, which is interpreted as the number 2, which is one of the elements in the domain. And finally, we have 2 predicates, p and q. P has 1 parameter, q has 2 parameters. P is interpreted as a function which can decide if the parameter x is an even number. The other predicate can decide if you multiply the 2 parameters x and y, you get 4 as a result. Now, in this video, I'm only going to evaluate the first formula. The 2 other formulas are in the subsequent exercises, so you have to evaluate them based on how I evaluate the first formula now. Okay, so let's evaluate the first formula. It's a universally quantified formula, which means we have to decide if for all x, and x, the value of x can be in the domain. So x can have 4 values now, 1, 2, 3, or 4. So we have to decide if the scope of the formula, not px, or there exists y such that q of x and y is true. Okay, inside this formula, we can find a disjunction with 2 operands. And basically, what we have to check if any of those operands is true for all values of x. Actually, there are 2 cases if you think about it. The first case is that x is odd, which means x can be either 1 or 3. So in this case, px evaluates to 0 since x is not even, which means that not px evaluates to 1. And therefore, the value of this disjunction must be true at the, in this case, of course, because one of the operands is evaluates to 1. So this case was easy. What about the second case? The second case is when x being even, so x is either 2 or 4. In this case, of course, the first operand of the disjunction, not px, evaluates to false. So in this case, there is no other choice than satisfying the second operand. There exists y such that q of x and y evaluates to true. Okay, so let's see when this existentially quantified formula can evaluate to 1. Well, there must be such a y inside the domain that the scope of the quantifier q of x and y evaluates to true. This is what we have to prove. And now, of course, we know x can have only 2 and 4 as values. So let's check the first case. The value of x is 2. In this case, let's see if we can find a y in the domain, which if we multiply with x, we get 4. This satisfies q of x and y. Yeah, of course. So if we take 2 from the domain, then everything is all right, because you multiply 2 with 2 and you get 4. In the other case, if x evaluates to 4, Then again, we have to check if we can find an element in the domain, which if we multiply it with 4, we get 4 as a result. And of course, we can find such an element. If y evaluates to 1, then q of x and y is evaluates to 1. So to summarize, we proved that in this interpretation, what we can see, this first formula is true, and we proved this fact by checking out different cases. Basically, we did a semantic analysis by hand.